involving triangles. This is with variables in them, so it's a little bit on the more higher level questions. The question has a triangle PQR with angle alpha and side x given to me, but it's also given that those two sides are equal. So you can immediately write that this is also x. And then Nan taught you what you can do. Whatever you can do, you must do it in order to find all of the angles possible. So that would mean you got alpha where? By Q as well, because angles opposite equal sides. Do you need to write that reason? No, because you're not in geometry. But the fact is that angles opposite equal sides are equal, and then you can also find angle P, because it's 180 minus 2 alpha, because of the sum of the angles of a triangle. So once I've got all the sides, all the angles, then I can actually use the symbol, can't I? Question is find QR. So if I wanted to find QR, could I have possibly used the symbol? Are there pairs? Yes, there are. Why won't I go for it? Because the question actually said use the cos rule. And even if they didn't say use the cos rule and they said prove that it looks like this gave it away. That you should have used the cos rule. So let yourself be led by the question. They're telling you this is what it must be look like, so that's why I need to use the cos rule. So for the cos rule, we've got a square is minus 2c cos a, and that would mean to find QR that the question is, QR would mean I've got the other two sides that are both x, so it's x squared and x squared, 2 times x, and cos of the included angle there, 180 minus 2 alpha. And what is this? Reduction formula, it's a poof sign. It'll go 180 minus is poof, gone away. And you just left with cos 2 alpha, right? Not quite. What about the sign?
Oh, it has to change.
Is it going to be plus or is it going to be a minus? Minus, because you're in the second quadrant where cos is negative. But don't start subtracting, it's still timing. Timing with what? This would be x squared plus x squared, simplification is 2x squared. When I simplify this, I'll have minus 2x squared, still timed with the rest of it, but don't leave the bracket away because you might start adding instead of timing. Then this answer would be 2x squared minus, no, is it minus? That'll now be a plus because I'm multiplying and it's 2x squared cos 2 alpha, and then it makes sense that they've got their plus over there. But what did they do with their answer to get it from my answer?
They took out
They took out a common factor, and the common factor is 2x squared. Remember that previous one we also took it out, but we also put it in the square root. Why aren't you going to put it in the square root? Because they asked for it in the square form. So you listen to what they're asking you. You let yourself be led by what they're asking you. So that the answer, when you take out a common 2x squared, is 1 plus cos 2 alpha. Now most kids that would have made a mistake in this sum, I predict, would have been because they didn't have the minus there. They had a minus here somewhere missing and whatever, and then they manipulate. And remember, the answer is not worth a mark, even if it's right, because I gave it to you. So you can't manipulate to get it right and think that there's a mark to be had there at the back. Okay. Causal substitution, factorization would have been the marks allocated here. Question number 5. They told me a whole story here, and it's all about angles of elevation and depression, although everything's on the sketch. But they did tell me that this guy is standing there at point D on top of a cliff. Then he looks down at E and F that are ships on the river or sea or wherever he is, but they do distinguish between the angles of depression to E and the angle of depression to F. And listen carefully to their wordings. Although, guys, in the test, this is what's done. They give you the sketch and then they talk the whole story next to it. And they say, from D, the angle of depression to F is beta. angle of depression to E is alpha. And remember, it has to be from horizontal. The amount that of degrees that your eyes must go down, that's the angle of depression. Angle of elevation, if I'm looking at something there at the top, is also from horizontal line. How many degrees my eyes go? Upwards. So you need a horizontal line to be able to talk about angles of depression, or even elevation if you're going upwards. Alright, so that only means that the alpha and the beta is on the right place with all of that, but noting what an angle of elevation or angle of depression is. Ma'am taught you the first thing that you must do is find
Angles.
all the angles possible. If you can find every single one, all the better. Whether you're going to use them or not is another question. But what angles can I find in this sketch then?
D.
Angle D is what?
Angle
D1, are you talking about D1? Would be what?
D2.
You're talking about 90. Why is she talking about 90? I don't know that. They didn't give it to me. Because it's a vertical cliff and a horizontal line. Anything vertical, whether you're on top of a building or wherever, if it's a vertical space that you're on top of and the horizontal has to be 90. So if this whole angle is alpha, then there should be 90 minus alpha. Do you agree? Beta and alpha here. That PC is beta. That whole piece is alpha. So how much is this? Not beta minus alpha. There's a vast difference. And if you're wondering, let's say the small one was 20 and the big one was 60. How much would this have been? 60 minus 20. Well, how did you do that? The bigger one minus the smaller one. The bigger alpha minus the smaller beta. Does it make sense that you would get that little value there? So I've got all these. How many triangles in this whole sum? 3 actually. Okay, because you can even use the big one, but the x is only in this triangle. So you're going to need to work with the side. Remember, you have to have at least one side to work with. So if I'm going to work with this x, I've got to work with this triangle. And to work with the big one, I might have to do a little bit more, but it's an option. Okay, the first part is, okay, I'm not there yet. Can I get some more of these angles?
Yes.
Where? E, which one?
E1.
E1 would be?
Alpha.
Exactly how? Some of the angles of triangle? Or
Alternate angles.
alternate angles. Because remember that horizontal line. And the horizontal line here on the C is still both parallel. In any circumstance, if I've got a horizontal here and a horizontal there and a horizontal there, they are all parallel to each other. And they don't have to give it to you. So you should know that if that is alpha, then this will also be alpha. Or you could have done some of the angles of a triangle like you always do in trig. But you've got that alpha, right? So, and then also for E2,
180 minus alpha.
straight line. Do you agree? Let me do it another way. How much would F be?
Beta.
How come?
Alternate
Do you see the alternate angles there as well? With the parallel lines there? Do you see the Z? To get there to beta and beta. Why again? Because of the parallel horizontal lines. Do you see it?
Yes, ma'am.
And then, could I not have gotten E2 by saying some of the angles of a triangle? It's harder. It's much easier just to say straight line is 180 minus alpha, and it has to get you the same answer. Check it. If you say that one is 180 minus that plus that, that plus that is just alpha. So it'll still be 180 minus alpha. So it doesn't matter, alternative techniques, you've got to get to the same answer. Do I have every single angle I could possibly use here? Yeah. Okay, now I can look at the question. That's normally what I do. Find all sorts of things, because now they needed me to find DE, which is actually the connector side, you see. So am I going to use that triangle with the X, or am I going to use this triangle? The question says, find DE in terms of H. That means I've got to go to this triangle, because they're leading me there. So in that triangle, and I'm coming there, DCE, in that triangle, how do I find DE? So can I use the symbol? Can I use the sin rule? Have I got pairs? Because remember now, I've got H, because I want it in terms of H. So I've got a pair. The one I'm looking for, the pair is 90, so you can use it. Right? How would that look? Whether you put the angles at the top or bottom doesn't make difference. I'm going to want to use DE, so it's going to be on top of sin 90, and sin 90 is going to just disappear magically in the next step because sin 90 is 1. Knowing it from your sin graph, that sin 90 is 1, sin 180 is 0, sin 270 is negative 1. So you're going to know that that is 1, and it's just going to fall away in the next step. And the other side that I've got is H over sin. So I'm not using the 90 minus, and I was so looking forward to a poof puff. At the moment I've got sin 90 minus, it's going to be poof puff. Are you with me?
Yes, ma'am.
All right. Let's have a look. So then to find DE, what's the answer?
H
H over sin alpha. I did nothing. Ma'am, where's the sin 90 gone to? Are you with me?
Yes, ma'am.
That it was 1. Couldn't I have used grade 10 method there?
Yes.
Because there was a right angle triangle to find DE together with H, together with your given answer there. That would have been opposite over hypotenuse, which is the sin of angle alpha would be H over DE. How would you get DE alone? Cross multiplication, you see them. So the DE would still be H over sin alpha like there. And both those techniques would have been worth 2 marks. Sin rule or grade 10, but you can only use grade 10 method if it's a 90-degree triangle. Second part of the question says, please find D2 in terms of alpha and beta. Oh, we're done. D2 was alpha minus, because they're leading you to get all the things that you need to find the next question. We're going to do it on that side. Okay, the part C and D of this question was show that H is equal to. Okay, I just found H. Or did I? I know that H can be written now as D times sin alpha degree. But obviously they want it in terms of X. So I had to go work with triangle DE. If you see that they don't say, listen my child, you've got to work with DEF. They throw it to you and you've got to sort out. How am I going to solve this problem? If they want an X in this answer, they need the H. But the H is in terms of DE. You see it?
Yes, ma'am.
So you can use this DE that you now have inside of that triangle to get to the X's as well. But nobody's telling you that. You've got to sort it out. So if I'm going to be working in triangle, DEF, it's just good technique to say it like that. You're going to be working with the sin rule, right? If I have already written the sin rule here, I'm not going to do it again. You can if you want to, but you don't have to do it again. So then to find those in proportion to each other, do I have sin rule? Can I use sin rule here? Yes, because you've got 2 sides, you've got all the angles, and you've got pairs. So that's fantastic news. So if I then want to say X over the question, which one is actually the question? This one's got an H in it, that one's got an X, so which one is really the question? It doesn't matter if you want to say X over sin alpha minus beta and this one over sin beta. It doesn't really matter which one is first. So X would be over sin.
Alpha minus beta.
Right, I'm starting to think I'm on the right track. Also, that was a clue. If you wanted alpha minus beta, you should have worked in that triangle. Also, if you wanted the X, right? And the other side would then be what I have already. Remember, these sums work like scaffolding, building on top of each other. They wouldn't have let you to do this if they didn't want you to use it. So they want you to use DE. Now remember, I do have DE. My technique is just always to write it first and then substitute with a large thing. So DE over?
Sin beta.
Okay, and then I'm not quite sure what I'm going to do over here. Definitely just not sin alpha minus sin beta. You cannot sign the sin in. Are you with me, guys? You don't do that, I know. On that side, then I still have to substitute the DE with.
H plus sin alpha.
Okay, does this make sense? That's what I'm just going to do now. Instead of saying divide that by sin beta, can I write times 1 over sin beta? Because you're going to have to sort out the problem of 3 things on top of each other sometime. So it's a good technique to also now learn. If I know DE is a fraction, I don't want it like that. I'd rather say instead of divide by sin, times with 1 over sin. Does it make sense? Right? And then I still need to do what? What's the question? Focus.
Find H.
Find H. So I need H alone, not X. Focus what you're wanting here. So I want that H alone. So what's going to happen to those 2 things? Time it to the other side. You've already got X and sin alpha minus beta. So if I times with sin alpha, it's going to be at the top, right? Because when you time and you've got fractions, the timing goes to the top, division goes to the bottom, and then sin beta. Nobody was stopping me first timing the sin beta and then timing the sin alpha, but good methodology is always to keep it in the same order as what they've given it to you. It's right if you say sin beta times sin alpha, no problem. You can swap it around, but please give it to them as they asked it. Okay, I left too much space here, so let's go to the last question. Here's the question that everybody can get some marks for. Even if you were able to do nada, they told you to prove that H is equal to. Then they're giving you X, alpha, and beta. So here's a 2-mark question for everybody, level 1. Just substitute the X and the alpha and the beta, and then get your answer for 2 marks. Even if you could do nothing else. So to substitute, the X would have been 250. Sin of alpha, which is 65. Sin of beta, which is 30. And because I don't have a lot of space, sin of alpha minus beta would be 65 minus 30. Or if you really want to write it, it's fine, 65 minus 30, no problem. Because I just need the answer. You don't really have to show me that this is 35. Just type it into your calculator, give me the answer, and the answer is
197.
197. Exactly.
197.51.
Okay, and they never said something about meters or whatever, so I can leave it that way, or I can say units, or just